Hello everyone. Today we're going to talk about the project disease for the Mentorness internship. We started off, as you can see here, by importing all our libraries so that the notebook is clean and clear. So we started importing everything at the start, and then later on we read the CSV files, train and test. We checked the types because we want to know what our columns, what type they are, since when you have a look at the data, it's numerical. So everything here is numerical except for disease, which is an object. So we gotta figure that out. As you can see here, we display the both train and test. They're all numerical values. As we said, for except for disease, which has healthy or other types of diseases, and these other types are either diabetes, taras, anemia, or thromboc. And so we did a distribution of disease status in training data just to have a look at which one is prevalent, and it's anemia. Um, and so we did a mapping to encode both train and test data sets. So 0 means healthy, not sick, and 1 is for all the other the diseases. So 1 means sick. And that's how we encoded the disease column. We also dropped rows that have non values from test. We cleaned the test data set because we had some problems there, because they said that we have non-values there. And we separated features in the target variable. Our variable is disease, so we separated both train and test into x train, y train, and x test, y test. And we scaled our data set, of course, and we did a standardization of the feature columns, because that's important in machine learning. It's a step that we cannot skip. Afterwards, we started working on our models. The first one is obviously regression. We started with logistic regression. As you can see here, the results show that we have an accuracy of 0.69, nearly 0.7. Precision is also very extremely high. And the recall is 0.69, F1 score is 0.81. Um, and then we did cross validation just to see where we are in terms of accuracy scores, etc. And it shows that the accuracy is very, very high, which is normally it would be a good thing, but now it just makes us doubt whether this is actually truthfully working or not. Because when you have such a high accuracy, such a high cross validation results, it means that our dataset is imbalanced. And so we tried to balance it out and use models that are best fit for imbalanced datasets. And as we can see, the training class distribution shows that there's like 1,795 instances of class 1, and just 556 instances of class 0, which means that truthfully there's a class imbalance, with class 1 being the majority class. It's beneficial to just look for other classification algorithms that treat imbalanced data sets, just like ensemble methods. And we started off by balanced random forest. Here's our results. We found that we also printed a confusion matrix just to see true negatives and false negatives, and true positive and false positives. And our accuracy is high, as is our precision, or recall, our F1 score. This just means that our model is performing very well. And then, second of all, we also did a cross validation. The accuracy is still high, but that's okay because our model is fit for imbalanced data. So even if this cross validation results are very high, it's normal. And so we're using a balanced random forest classifier, and it's designed to handle imbalanced data. So the model is indeed performing well. Second of all, we used XGBoost, and our cross validation results are also very high. It shows that our confusion matrix shows that 392 were correctly classified, and we only have five false negatives, and one false positive. So the cross validation results basically indicate that we have high performance across different folds, and this just shows that the model generalizes well and it's not overfitting to the training data. Same for light GBM. Our results show that we have no false positives and no false negatives in the confusion matrix, and this just shows that we have no deviation in accuracy scores. And basically the model generalizes very well, and it's not overfitting at all to the training data. Fourth model is gradient boosting. Same, we had three false positives and two false negatives. Our, as you can see, accuracy, precision, recall, and fun score, they're all high, and so it's just meaning that the model generalizes well, it's not overfitting to the training data. Five is balanced bagging. We had two false positives and three false negatives, which is a bit similar to other models. The model is performing very well. We also did at the end. This is the end. We did the plot. We did a figure of all a comparison of evaluation metrics for different models, because the values are very close. So we did a plot. A comparison of metrics of all different models, and we see obviously that light GBM, if we prioritize accuracy, it's light GBM as the best model. We will select that. If you want precision, it's either light GBM or XGBoost. And if we want recall, it's also light GBM. If we will prioritize F1 score, we might also consider light GBM. So overall, light GBM is the best choice of model to work with. And that's it for our dataset. Thank you.